Okay, all right. So today I first want to go through your assignment submissions. I know you guys probably didn't find the assignment part too hard, but it was mostly the GitHub, Travis, all that, right? So using all those tools. So I want to show you actually what, from my side, how things look like. And so it was done on purpose because, as I mentioned many times, I really value the tools. And when you become an engineer, a software developer in one company, you guys are responsible from like end-to-end process, right? It's not just writing the code and then you are done. You have to make sure your tests run, you have to make sure everything is deployed, so you are responsible for all that. So I was trying to convince you that you should be aware of it, and so you'll get credit if you do it right, of course. So for example, so let's see. So most of you were asking me if your assignments passed the test or not in Travis. Well, for that, you don't actually need to ask me. You can just go to, for example, this was my my repository, right? As a student, let's say I'm a student here. And then all I need to do is I can just look at my commits. And here, my commit, that means it failed. See, the build failed. So here I can tell I'm not doing something right, okay? So for example, for Alessandro, he can actually see this green tick in his assignment. So that means he's good. He's gonna get 100, okay? And if you, so for the next assignments, if you guys submit this earlier, so sooner is the better, right? So when you do that, I can actually, for example, I can go to here, I can actually say, hey, your tests are failing. And then we can start a communication here. We don't even, yeah, you'll get an email with that too. But here I say, oh, okay, please do that. And then he's like, oh, okay, so let's fix that. So I can help you if you submit it earlier, okay? So if you do it in the last minute, I really don't have much time to debug your code and do everything. So going forward, be aware of this. And what else do I see? Okay, maybe you shouldn't see all this. Okay, for example, here I can actually tell like, oh, this passed, this failed, this passed, this failed, all that, right? So by that, I'm gonna grade your code. I'm actually being super lazy. I'm making you guys do all the work, and also computers run for me. So the rest is for me is just like, oh, okay. So if the test, all the tests pass, of course you are gonna get 100, full point. If there is a failure, then I'll go through, and let's say there are like 15 tests to pass, and you pass, let's say, 10 of them. Then I'll take the percentage for your points. Okay? All right.
Travis is checking our code for accuracy, but it's also checking it for like plagiarism, right?
It's not done in plagiarism. So, I mean, maybe I can set that too. It's actually not a bad idea, but we are using another tool that the grader actually runs another extra code for that. So, for example, so you are committing, right? Every time you commit something and you get a commit ID. So if two students have the same commit ID, obviously, right? So they copy it from each other. Or if there is so much overlap between the files, that also indicates plagiarism. Okay. So do you have any questions about the assignments and or how to do things in general? Yes?
Is the test that we're running locally to see what Travis is testing for?
Yes, exactly. Yeah. So you know what you are failing, actually. But sometimes if things pass locally, but they don't pass in the cloud or Travis, that means there's probably something wrong with your setup file or YAML file, all that, you know. So you need to debug that one. But most of the time, if things are good in local, that should be good in Travis too. Okay. Any other questions? So every time you push, it will run all the tests. So, and I'll take the latest push you guys have. Okay? All right. So let's continue with the lecture. IPython notebook material. So again, I need to CD to all my files, so you guys can use your own folder. And I'm in courses, this, lectures. Okay, and then I'm gonna go to my my environment, because that's where I have IPython. Okay, and the rest is Jupyter Notebook. Okay, so let's get started. So far, as you have noticed, we have been using variables without declaring their existence or types. Yeah, it somehow works, right, in Python. So for example, when we type a equals 3 in an interactive session or some program file or instance, so Python knows that a should stand for an integer, right? So we have done this many times. So how does Python know what a is at all, right? When we run this a equals 3, how does it know it's operating on an integer? So yeah, asking those kinds of questions, you are actually stepping over the domain of Python's dynamic typing model. So in Python, this is important. The types are determined automatically at runtime, not as a response to declaration in your code. So for example, so when we say this to assign a variable a value, I was thinking if this a is actually the variable a here, but I guess it's not. So when we run this, so Python is going to perform 3 distinct steps. So these steps are, first, it creates an object to represent the value 3. So there's one object in your memory for 3. And it also creates a variable a. I actually want to make this like this. So, you know, it's the variable a. So it creates a variable a. If it doesn't exist yet. If it already exists, it's gonna just change the pointer. And then it links the variable a to the new object 3. So basically, if we want to use a figure for this, for what we just mentioned, so you will have names, for example, a as a name, and then there will be an object 3. And a will refer to this object when you run a equals 3. Okay? So here we are basically just using a pointer for a. And that pointer points to the object 3. Okay, so types live with objects, not variables. So in this figure, for example, the information, the type information is actually here, not here. So for example, when I run a equals 3, so this is an integer, right? It's pointing an object, integer. And then I can just change what a is pointing by running this, by making a equals spam. In this case, now I'm actually taking this this pointer and point it to somewhere else, which is spam in your memory. Or I can actually change it again, which is a floating number. Okay, so all we are doing is create an object. Every time we created like 3 different objects, and we have one variable a, and we just change what it is, what object it's referring to by doing this. Okay, so again, names have no types. Types live with objects, not names. So we simply changed a to reference different objects, okay? But objects know what type they are. So each object contains a header field that tags the object with its type, okay? So as I said, so here there's a header field where it knows it's an integer, for example. Yeah, so the integer object 3, for example, will contain the value 3 plus a designator that tells Python that the object is an integer. Okay? So is it confusing or does it make sense? Makes sense, right? So you understand the difference between objects and the names, basically. Okay. Okay, so garbage collection. We talked about this already. So basically, when we reassign a variable, what happens to the value it was previously referencing? So for example, after the following statements, what happens to the object 3? So I had this a equals 3, a equals spam. So in Python, whenever a name is assigned to a new object, the space held by the prior object is reclaimed if it is not referenced by another name or object. So the object space automatically thrown back into the free space and to be reused for future object. And this automatic reclamation of object space is known as garbage collection in Python. Okay, so basically here the first space for a, after we run this a equals spam, this will be garbage collected. So what is the benefit of this? It actually means that you can use objects liberally without allocating or freeing up a space in your script. So Python will clean up all the unused space for you as your program runs. Okay, so the name garbage collection actually, I think it's pretty clear what that means, right? Okay, so what about the shared references? So what if I have a equals 3 and then I have b equals a? So does it create another object for b to point to? Well, so typing these two statements generates something that's captured in this figure. So we run this, a equals 3, b equals a. So we have 3 names, a and b, but we have one object, 3. So a was referring to this object 3 before. And then when we say b equals a, we are making b to point to the same object, basically. Okay? Is this clear?
Yeah.
Okay. So this is so when you have multiple names referencing to the same object, so this is usually called a shared reference. So what if I run one more thing? So a equals 3, b equals a, and then I say a equals spam again. So do you think it changes b, this output? Who says the b will look different. So b equals 3. Who says b will be equal 3? Okay. And who says b should be equal to spam? You're saying 3 too.
Yeah, I said spam.
Okay. All right, let's see what happens. So b is 3. Didn't change it. So what happened here? So basically, initially they were both referring to 3, like here. Initially they were both referring to 3. And now we changed A to refer to spam. But B stayed the same. So B is still 3. It's not spam. Then it will be 3 again. You wanna try? So B equals A, print B. So now it is spam.
So it does it sequentially, essentially, pretty much. Like if you scroll up a little bit, it was like A equals 3, B equals A, and A was, now points to spam. So it does it sequentially, doesn't like look through first, like.
Yes, very good point. So first it runs this, and then it goes through this, and then that, and then when you run another statement, it just follows from where it was left. Okay. So basically, what we had, so when B was 3 before, it actually got garbage collected, and now we have a new B, which is spam now, which points to spam. Okay. Okay, so this is something you need to be really careful with the shared, when you have both shared references and also in place changes. So there are some objects that we can do in place object changes. What are those? Those objects? You can basically just read here. So basically those are mutable types, right? So with the mutable types in Python, you can do in-place object changes. If you remember from last week, we were actually using, for example, for sort, it was able to change the list that we defined in place. So you can actually do these kinds of in-place object changes for the mutable types, lists, dictionaries, and sets, right? So for these objects, the mutable objects that support in-place changes, you need to be really aware of the shared references, because a change from one name may impact others when you have the in-place changes. Otherwise, your objects may seem to change for no reason. Okay, so what do I mean? So let's illustrate. So this is a list, right? List is a mutable object, right? So we define this list, 2, 3, 4. And then let's make a reference to the same object. So L2 points to L1. And so now we make a change in the original list, L1, by assigning 24 to the first index. Okay, so what do you think L1 is going to look like? Yeah, 24, 3, 4, right? And now what do you think L2 should look like? 2, 3, 4 or 24, 3, 4? Okay, who says 2, 3, 4? You say 2, 3, 4. What about you? You were saying spam before. No? You don't want to say anything? You say 24, 3, 4.
Yeah.
Okay. All right, let's see. Yes. So it changed L2 too. So this is something you need to be careful, right? So you may not have an intention to change L2. So what happened here? We changed the component of the object that L1 references, right? So that actually overwrites the part of the list object value in place. So we changed the list in place because so because the list object is shared by other variables too, like L2, now this change doesn't only affect L1. So it also changes L2 because it references to the same object as L1. Okay? So again, we haven't actually changed L2, but its value will appear different because it refers to an object that has been overwritten in place. Okay. Well, of course, in Python, you may not want to have this result all the time. So what do? So there must be a way to avoid this too, right? There must be a way when you want to make an in-place changes, but not with all the variables. Well, so for that there are some different ways to do that, but that what I illustrated was the default. When you make L2 equals L1, when you change L1, then L2 will change. If you do it this way, that's the default way that Python acts. But you can either use Python. Basically, you can request Python to copy objects instead of making references. So you are telling Python, okay, I don't want L2 and L1 share the same object, share the same reference. Just copy whatever L1 has, just copy it and create a new one so they will become independent. There is a way to tell this to Python. So one way is this kind of syntax. So L1, 2, 3, 4, and now when you create L1 with a column, then that actually makes a copy of L1. So now they don't. So the value of the objects they are referring to are the same, but those objects are different. So basically, when I do this, L1 equals L2, and then I change L1, first value of L1 to 24. So this time L1 of course changes, but L2 doesn't. Oh, wait. Oh, because I didn't run this one. Let's start again. So L1, 2, 3, 4, and I make a copy of that, and I change the first value of L1. Look at L1, look at L2. So this time L2 didn't change. Because when we do this operation, we created an object which is 2, 3, 4, another one, exactly the same one, 2, 3, 4. So you basically made them almost independent by copying everything. Before we were not really copying, we were just pointing to the same object. Okay? Is this clear, everyone? Okay, good. So Python also has this standard library, copy module, that has a call for copying any object type. So for example, what you need to do is you just say import copy, and then let's say we define this list L1, which is a list of lists, right? So this is a list of lists, right? What is the length of L1, by the way? 2, yes. So let's create two lists by using this copy. So basically, I'm importing copy. So I say copy.copy L1. So this makes a top level shallow copy of any object. So here, what I'm doing here is actually exactly the same as what I did here. And there is also a way that does deep copy. So one of them is a deep copy, one of them is a shallow copy. Okay, so let's see what happens. What I mean by shallow and deep. Do you have any intention, any instinct about what deep and shallow copy might mean? Does it look confusing at all? Yeah, okay, so let's do this. So we have this list of lists, right? So let's modify the first value of the first list of L1. So I have this L1 0 0. Oh, I forgot to run this again. Okay, so let's run this. And now run this. Okay, so I obviously changed L1, right? So if I plot print L1, this is how it looks like. Okay, so for L2, who thinks L2 should have changed? So you think L2 shouldn't have changed? No? L3? Okay, so who says L3 should have changed? You say L3 should have changed. Because you think because it's deeper? Okay. Yeah, makes sense. Yeah. All right, let's see. L2 has changed. L3 didn't. So the opposite of your intuition is correct. Okay. So basically what happened here? So this, when I say shallow copy, it copies the first ones, but in this list, in the first list, it shares the references of the first list. So yes, so it creates two. So for L2, for L1 we have 2, 3, 4. For L2, it creates 2, 3, 4 list, but actually for each entry, they both share 2, 3, 4. So they are kind of, so 2, 3, 4 are shared. So it, maybe if I do, okay. So let's do this. 4. So let's go back to the original list, okay? So in this case, deep and shallow copy should be the same because we don't have much deep list. So we have our list is already shallow. So I changed this. Oh, because it doesn't work, of course. I changed this. I changed L1. So this time, L1 is this. L2 is this. L3 is this. So this case, it didn't change L2 because L2 copied all 2, 3, 4, and L3 also copied. So since it's a deeper copy, it copied everything. But when I have this, only, then it's actually, so it only, for L2, it only copies the objects in terms of like, it only has a shallow copy of the objects. So if I do this, so for L1, yeah, I modified L1, but L2 should change too because it was a shallow copy. For the deeper objects, it was still using the shared references. It copies only in the higher level. But for L3, since it's a deep copy, it copies everything. Okay, I don't think you are convinced. So let's do this. So now, let's change the first list. Okay, So I'm gonna run this again. So I'm changing this 2, 3, 4 with SPAM. Okay? So I'm making a higher level modification. I'm not changing like L1 0 0. I'm changing just the list in higher level. So of course L1 is going to look like this. And oops. Okay, so L2 didn't change because I modified it in shallow level. I didn't modify it in deeper level. I modified it shallow level, and for shallow level, it already copied the shallow objects. And for L3, it's also not going to change. But if I want to make a modification with L1 for deeper level, so in this case, since L2, L2 only uses the shared reference for deeper levels, so L2 is going to change, but L3 is not. Okay? So if you want to make changes for all the objects in deeper level, so I just recommend to use deep copy if you want to change everything. But if you don't have a deep structure, if you have just like one list, doesn't matter which one you use. Okay? All right, so shared references and equality, we talked about this a little bit last week. So basically, let's create a list L. And then now when I say M equals L, it doesn't copy, right? It only makes both M and L share the same reference. And now, so who thinks M equals L is going to output true? Should that be true or false? This should be true. Why?
They're pointing at the same object.
Right. Okay. What about M is L? Is this true?
No.
Why is it false?
It's not looking at the objects, it's looking at the names.
Yeah, but they are pointing
It's the same.
the same object. All right, let's see. It is true. Because when we run that, let's go to, so basically when we say A is B, we are actually looking if this is exactly the same. And then we say, okay, yes, they are referring to the same object. It's not a copy. If it was a copy, then that could have been different. So let's now make a copy instead of just changing the reference. Okay, so now we create L and M exactly the same value of lists. Are they, you think they are pointing different objects or they are sharing a reference? Different objects, right? Yes. Okay, so when you check L equals M, is it going to be true or false this time? Okay, what about this? L is M. This is going to be false, right? Because they are referring to different objects now. Although their values are the same, but they are different because we created two different objects here. Okay, makes sense, right? Well, okay, so this was for the list. What happens if we perform the same operation on small numbers? So let's say x is 42, y is 42. So x equals y, this should be true regardless, right? As long as they have the same value, right? But this time x is y, no. So this is true Because for small integers and strings, they are cached and reused. So that's why they actually reference to the same object when you use a small integer and string. But when you create a list like this, it actually creates entirely a different object. Okay, any questions so far?
That's the difference between mutable objects and immutable objects.
Here it's not, so we are talking about in-place changes now, and for in-place changes you cannot do it with immutable anyway.
But if it's immutable object, so the different pointer will point to the same object, but if it's mutable, so even though the value is the same, but it will create different.
Okay, so basically you are saying this. Okay, so let's call this T because it's a tuple, right? T2, 3, 4. Oh no, let's make it 1, 2. Okay. So T1 equals T2. What do you expect? Yes. And T1 is T2. False. Because it should be false, right? Because we created a new object, although the values are the same, but it's a new object.
So just number, so just integer or string is true, are the same.
Right. Yes.
Or just integer and string.
Yes. Yes. So for integers and so basically for single values, the objects are just being cached. So it doesn't create all those numbers for you every time. Okay? Yeah.
What's the difference between small integer and big integer? You mean you said that it can be true when it's small integer.
Right.
Yeah.
Okay, yeah, that's a good question. I wonder if we have. So basically, what I tried to mean was more like if you use a number over there, it should the object should be the same thing you are referring to. But
Find some bigger number, but it's false.
right, let's try. Yeah, I think it should still be true. Oh, very good observation. Yes.
Yeah.
Yes. So when it is a very big number, it copies the number. Yeah, it's interesting. Where is the cutoff? Yes. So that's a good question to know.
So how about a very long string?
Okay. Is this long enough?
No.
Okay, maybe it wasn't long enough. Yeah. But in general, you know, if you are working with reasonable numbers and strings, it should be the same. But you should just be aware of this. Okay, so if this is something important for your program, keep in mind that ask yourself if they are sharing the object or if they are just copying the object. Okay. Any other questions? Actually, I want to change this to 42. Before we move to introducing Python statements, any other questions? Okay, so before we move on, let's have a quiz now. Okay, so how was it? Very easy, right? No? Do you want me to go over it? Okay. All right, so for the first question, which three of Python's core types are considered immutable? B, right. Blah, blah, blah means that the meaning of an operation depends on the objects being operated on. So what is this blank? C, right? You made it wrong?
Yeah, I choose the right, but I don't know the sentence.
Oh, okay. So you got it right just by chance?
I just know it's not immutable. The immutability is not memory is not
Uh-huh.
connected, so I should say.
Okay, that works. Okay, so which statement computes square root of a number x? All right. So what is this? A, right? Okay. So this is just bit shifting to the left. Okay. So which statement about sets is false? A, right? They cannot have duplicate values. Okay, so what's the output of this? B or D? D, right? Okay. Okay, so which statement throws an error?
D.
Okay, decide, C or D? D, right? Why? So this is a tuple, right? Nice. Okay, so for this one, which one is true? I mean, what's the answer? D, right? Okay, so it seems like it was easy for you. You did it right. Okay, any questions about this? Okay.
The
Yeah.
output one means L is L2.
Sorry, which one are you talking about?
And 8 output one, that means 8 and L1 is L2.
Remember, is a different thing than equal. Oh, so you are asking what if it was is, right?
Yeah.
Well, this is already false anyway, right? So this is the values are not the same. But even if the values were the same, it will be false.
I saw that L1 and L2 are pointed to the same matrix.
Yeah, that's okay. So yeah, so this is another way of assigning values. So when I run this, I'm actually assigning the first list to L1 and second list to L2. Okay. All right. I hope you woke up. Okay, so let's move with the Python statements. So we are actually now getting closer to discuss about the syntax and also how to actually write a program in Python. So we mentioned this before, that programs written in Python are composed of statements and expressions. So expressions process objects, and they are embedded in statements. And statements, on the other hand, code the larger logic of a program's operation. So statements actually does something. You are telling a statement to do something, although each expression can be considered as a statement too. So here's a table that summarizes Python's statements. So we have been doing this many times. You can actually do an assignment. So the role here is creating a reference. So A, B equals good, bad. This means good equals, good is A, bad is B. Or you can also do some other calls and other expressions. So basically, we are just writing a method right here. Or print calls. And of course, as any other Python language, we have these if-else statements, right? So so this is like a logical selection, but we are going to talk about it today anyway. And you can also do the iterations with for else, and also more general loops, while else, and also pass, break, continue. All this we will talk in the loops. And you can also define functions. So hopefully next week we will start writing functions. Yeah, so we'll talk about all this. But import statement you should already be familiar with. We have been using it many times, right? Import copy, import math, yes, import random, all that. Yeah, okay, so for the rest, this is, yeah, we will be talking about them in the next weeks. So, okay, so in terms of syntax in Python, so this colon character has actually special meaning or importance. So almost all Python statements or statements that have other statements nested inside them follow the same general pattern of a header line terminated in a colon, followed by a nested block of code, usually indented underneath. So basically, so indentation is really important in Python, and usually, so this is the general structure. So you have some header line, and you have a column here, and then you have some statement here. And so in Python, also parentheses are optional. If you took classes with like C programming language classes, you know that you have to be you need to put these parentheses. But in Python, they are actually optional. And if they are optional, why should you type extra? So basically, I don't see a reason of writing this. So end of line is end of the statement in Python. So you can, I realize I haven't been running things, but so you can either run this statement and put a semicolon, but you don't really need it. So Python understands that it's the end of, so we are at the end of line, and that's the end of the statement. Okay? And so end of indentation is end of a block. So for the statement, end of a line is the end of a statement. And for a block kind of statement, the end of indentation is the end of the block. So you don't really need to include begin, end, then, or NF or braces around a nested block as you do in C-like languages. Like for example here, you see you have like, so you don't need these parentheses in Python. You don't need these curly parentheses in Python, and also you don't need these semicolons. So we are actually saving. So in Python, all you need is this indentation if you have a block statement, and also the column, basically. So we already saved just in like 1, 2, 3, 4 lines of code. We already saved how many? 4 characters. Oh, actually 5, 6. You have these two. You know, so in Python, we consistently indent all the statements in a given single nested block the same distance to the right. So Python uses the statement's physical indentation to determine where the block starts and stops. So here it knows that you are starting the statement in a block here, and then when you are done, so at the end of indentation you are done. But Python doesn't care how you indent. You may use either spaces or tabs, or how much you indent. So you may either use any number of spaces or tabs. So indentation of one nested block can totally look different than another one. Let's say you have two different if statements, and the first one can have just tabs, the second one can have just spaces, which is not a good practice though. So it is always good to be consistent with your indentation. Whether or if you use spaces, keep using space. If you use tabs, keep using tabs. Yeah, so it's actually a good thing to have this indentation rule that actually makes you a better or cleaner programmer. It kind of forces Python programmers to produce more regular and readable code. So, you know, they will always look like this. If you have extra if statement, there will be like blah, 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 blah. And then if you have another, you know, so they will always look cleaner than the other programming languages where indentation is not a big deal. I mean, even though in C you don't need indentation, or maybe some other programming languages, it's always a good practice to start with indentation when you have these nested blocks. Okay? So it's a good thing. It's not a problem that Python forces you to add indentation. So of course there are some special cases. So in Python it's possible to squeeze more than one statement onto a single line by separating them by semicolons. You know, so so before I could have just done this, but you can do, so Python understands this too. So it actually understands, okay, this is the first statement, this is the second statement, and this is the third statement. Okay. So other special rule for statements is the inverse. You can make a single statement span across multiple lines. So which is actually basically like this. For example, this is a single statement here. So I can, you know, so I can either do this like this. So this works. But I can also write it like that. So it works too. But to make it work, you simply have to enclose the part of your statement in a bracket pair. So it could be either parentheses or square brackets or curly braces. But you need to use one of those. So also for if statements, you can still do it. So if you have a single statement, if in your if block, if you have only a single statement, you can actually use it just like a single line. Oh, this was a markdown, but yeah. So this can save some spaces if you care about it. Okay, so let's do some simple interactive loop. So let's say you need to write a classic read, evaluate, print loop program. So here I say while true, reply, so the input will be taken from the user. And then if reply is stop, then I say break. And then print reply upper. So do you think this is an infinite loop, by the way? So what do you think this is doing? Do you have any intuition? And what does this while true mean? Isn't it always like infinite loop? True is always true, right? But there is a special case that I'm telling break the loop. When if the value of reply is equal to stop, basically, right? Okay, so let's run this. Okay, so it asks me to enter a text. So let's say Stevens. Okay, so here print reply dot upper, that actually makes everything capital, right? Okay. And I can keep continue. Okay, now if I say stop, it will stop. Otherwise, it will keep asking me. Right? So is this clear for you? This while loop. It is, right? Okay, so now let's try to do some math or some mathematical calculation with the input we have. So here again we are going to take the input, right? So this is same as before, and if what you enter is not stop, then you convert it to an integer and take the square, right? Is this clear? Okay, but what if I cannot run this operation, right? So a user needs to know that you can do this conversion. Okay, so let's run this. I can say 17, 3, and then Stevens. Okay, I got an error. Why did I get an error? Yeah, because this int function doesn't work for string, right? But let's say I knew about it. I say 3, 17, stop. Okay, so that works as long as I know what kind of input to give. But this is not very safe, right? So you should probably have some checkpoint where you tell your program not to run under such cases. Yeah, so exactly. So what happens when the input is invalid? Well, in that case, so again, I take reply as an input. And then if reply is equal to stop, I say break. And then if reply is not digit, then print bad. If everything is good, just take the square of the value. Okay. So I actually added this checkpoint here, extra checkpoint, in case I cannot take the square of the value, or if I cannot use this int method to for the conversion. Right? Is it clear what I do here? Okay, so this case, okay, 17, 3, and then I say students. Okay, maybe I shouldn't say students. Spam. So it ran this this statement because it wasn't a digit, but I'm still in the while loop, right? And now I can continue 7, and then finally I can say stop. Okay? Any questions on this? Okay, but so there are other ways to handle errors with try statements in Python. So it is probably the most general way to handle errors. So basically what you do is, what you say try this. First run this integer conversion. Well, if it doesn't work, you just say print. Otherwise, print the square of the number. Okay. So let's run this. 17, 3, spam. Okay, so it ran this, but I'm still in the for loop. And then I can continue and finalize this stop. Okay, so what you should pay attention here is this try and except. So basically, you tell Python, well, try this, doesn't work. So so you are actually fine with the error, more or less, in this case. So this is called a try and except statement in Python. Okay, we'll do more about this. So this is just to introduce you another way to handle errors. Okay, so yes, so this works exactly like the previous one that we wrote here, this one. But we have replaced the explicit error check with the code that assumes the conversion will work and wraps it in an exception handler for cases when it doesn't. Okay, so the words try, except, and else are all indented to the same level. Notice that. So they are all indented to the same level. So they are all considered part of the same single try statement, basically. So you might think that this else is actually associated with the if statement, but it's actually associated with this try, except, else. So usually, first of all, these are optional. The else statements are optional anyway. And then those else statements usually correspond to the blocks before them, which is the closest one. Okay, so in this case, the closest one is actually try, not if. Okay. So we can do some, we can go deeper. So we can have this nesting for the for loops too. So basically, again, I had this while loop, and then I take input from the user. So if it is stop, break, as before, and if it is not digit, then print bad. Otherwise, so basically this means everything is good. If everything is good, do the conversion on the input, reply. And if it is less than 20, print this. Otherwise, print the square of it. So basically here, you see all this indentation, right? And here, for example, this if statement corresponds to this else state, or this else corresponds to this if here. And this else corresponds to this if here. Okay? So all you do is you add indentation to the right every time when you start another block. Okay, is that clear? Okay, so for assignment statements, we have been doing this many times since the start of the class. So basically, there are different ways to do the assignment. So basically, when you say spam equals this spam, it actually it actually assigns the whole spam to this variable called spam. But when you have this comma between variables and also the objects, so the first one goes to the first one, second one goes to the second one. Okay? And let's say you have this spam here. Oh, okay, so this was for the tuple. This is for the list. So for the list, you can do the same thing. So the first variable corresponds to the first one. Second variable corresponds to the second one, basically. So you can also do this spam equals A, B, C, D. So here, A becomes S, B becomes P, C becomes A, D becomes M. And in this case, for example, when you have this star, this is for Python 3, but I've been talking only about Python 3 anyway. So A becomes the first S, and B will be the rest, basically. And you can also do multiple target assignments. So here, both spam and ham point to lunch. And augmented assignment is another way. So basically, instead of saying spams equals spams plus 42, you say plus equals 42. Okay, so this is called augmented assignments. So this was actually something borrowed from C language. And they are mostly just shorthand. And they imply the combination of binary expression and an assignment. So these two formats are actually equal to each other. And so it doesn't have to be just plus. Also for other operations, you can just use any operation. So basically, what it is doing is changing the value of x with the x and y and on that operation. Okay, yeah, I know these are not the most fun parts, but you need to know the syntax for Python. You need to get used to it. So there are also some rules for the names. So first of all, for the syntax, you cannot, so you can either start with underscore or letter. Let's say, so yeah, so you can use, but it has to start with underscore or letter. It cannot start with digits or underscores or anything. So the start of the variable name has to be a letter. You cannot create a variable that starts with 3. For example, let's try 1 ABC equals spam. Say invalid syntax. I cannot do this, but I can do this. Or I can do this too. Or I can add integers as much as I want. But you cannot start with numbers. So that's something you need to be aware of. So if you get an error when you create a variable name that starts with digits, then that's the reason. So by rule, you cannot do that. And so case matters. So uppercase spam is not the same as the lowercase spam. Reverse words are off limits. Oh, right. So reserved. Yes. So there are also reserved words in Python that you cannot actually assign any value to those. So of course, you cannot create a new variable that's name is false or true, or so any of these things, you cannot do that, basically. Okay, so let's move to the if tests and syntax rules for if statements. So the general form of an if statement looks like this. So you have one if test 1, and you run statement 1, which is the associated block with this if statement. And then you run another test 2 and statement 2, or you run a statement 3. But this is, so keep in mind that both of these, elif and else, are optional. Okay? Yeah, all parts are optional except the initial if test. So in this case, if 1, print true, of course, right? Because 1 is already true, so it's checking the value of this if it's either true or false. And in order to handle a false result, let's say if not 1, you can also add this as statement here. Okay? And you can actually do more complex if statements. So if x is this, print this. If x is box, what's up, doctor? As print run away, basically. You know, so this is how the if tests work. Or so if you are familiar with C, you know there are like cases or switches. There's not such a thing in Python. Instead, you actually do it this way. So if, for example, let's say you have multiple tests with different output for each. So basically, you just say, if this, print this, if that, print that, all that. So here, if choice is ham, then it prints 1.99. Okay, so let me ask this to you. Can you do this kind of, can you write this program without using if? Yes? Is there any object type that you can think of where we assign if choice is that, so this is the value, if choice, Dictionary, yes, perfect. Yeah, basically you can actually write a dictionary. So what should we call it? Let's say menu. Okay. So here I'm going to say spam is 125, ham is 199, and x is 0.99, and finally bacon is 110. Okay, and then I'll say choice. So choice was ham, let's say, and I can say print menu choice, right? So this is this should act exactly the same way as all these if statements here, right? So let's run this. Nice, it worked. So this is just another way of doing it. But here, for example, we had this extra if statement, which was so if you don't have any of those options, you basically just print bad choice for this, right? So can we add that here too? So there is actually this get method. So let's see what get method does. For example, menu choice get. Oh, sorry, it should be menu.get. So basically, you give the key, and you also give the default value. So if it doesn't have the key, it will run the default value, whatever you assign. So basically, I can write menu get choice and default is, what was I using there? Bad choice. Okay, so let's change choice. So let's make it apple, which we didn't define in our menu. Okay, let's make apple juice. It makes sense. Bad choice. Okay. So just to remind you that you can also remember other object types that you learned to implement things. Okay. Can we also do? Can we do the test with the in membership too? So if you remember from our class with the dictionaries, you can actually say, okay, let's say choice is again ham. So basically you can say if choice in a menu, you can say menu choice as bad choice, basically. Oh, I forgot to do prints. Right? So here what I'm trying to remind you is that you can actually use this choice in menu so that actually understands to check if menu has this choice as a key. If it doesn't, you basically do the bad choice. Okay? All right, so what about, can we do the same thing with try that we just talked about? So anybody wants to walk me through this with try? Okay, so what was it? So we say try, print menu choice. So let's do choice again, ham, except print right. So it tries to run this. If it runs, that's fine. But what if I have apple juice? So first it tries to run this, and since it doesn't work, it goes to this block and says, okay, it's bad choice. Okay, so there are different ways to actually do exactly the same thing, basically. And actually, at this point, we just switched to using dictionaries. So keep that in mind. If you have something like this where you need to write so many if statements, if this, run this, if this, do this, if that, do that, then think about dictionaries, right? So it's easier to code. It's actually simpler, and it's also very fast anyway. So access to the values of sets or dictionaries is pretty fast. Okay? And also for exception handling, we also showed that we can actually use this try and except statements. Okay, so to summarize, so in Python, this is usually how it works like. So you have some block, and then you have a header line where you need to add these columns, and then you do indentation, and then you run another block, and then you can start another header line and start another block. And here, when you don't indent again, that means you are back to block 1. And then here, you are back to block 0. Okay, so is everybody clear with this figure? Do you understand what that really means for nested blocks of code in Python? Is it not clear? Okay, so let's look at the code, which does exactly the same thing. So basically, you have you start with x equals 1 here, which is block 0 here. So this is block 0, and this is block 0 too, because they are in the same level. And then you start another if statement, and now so that if x is actually this header line, and you start block 1. So this is block 1. And then with another if, you start block 2. So now we are here. And then when we unindent, we are back to block 1. And finally, this is block 0. Is this clear? Do you understand that this is exactly the same? So this is to represent what I was trying to depict in this figure. So basically, yeah. So first it goes to block 2, and then block 1, block 0. Okay, so one rule of thumb. I mentioned this before, but I want to say it again. So although you can use spaces or tabs to indent, it's usually not a good idea to mix two within a block. So use one or the other, okay? So technically, tabs count for enough spaces to move the current column number up to a multiple of 8. And your code will work if you mix tabs and spaces consistently, but such code can be really difficult to change. And mixing tabs and spaces makes your code really difficult to read, who is completely new to your program, basically. So if you guys watch Silicon Valley, I actually put this. So basically, the guy didn't want to hire someone because he was just using spaces, not tabs, and the main character was into the tabs. You know, so there can be huge fights about it. Can be a big deal. Okay, so for if and as, you know, so you can either write a statement like this, or you can just write the same thing with one expression. So basically, if x is true, make a equal to y, otherwise make it equal to z. So these two statements are exactly the same. Basically, just like one line, you can do it. Okay, so you might see this pretty often when you read someone else's code. So for example, here, a equals t if spam as f. So what do you think the value of a is here when I run this? What is a equal to? Huh? What's that? F? Why not spam? So think about this. So if spam, is this true or not? True, right? As long as it's not empty or none in Python, as long as you have something here, that takes it as true. So if this is true, make a equal to t. Otherwise, make it equal to f. So in this case, let's print a. Right? So what about this? So a is equal to t if this, otherwise f. So basically, so is this true if empty? Is that true? It's not, right? So this is false. So if it was true, make A equal to T. But since it is false, make it equal to F. So this is going to be F. Right. Okay. Okay, so we worked with while loops a little bit, but more generally, yes.
What is the, up there, the if statement testing?
So this is exactly, you mean for this one?
Yes.
So let's see if this will make it clear for you. If this T as those F. So you agree that this is exactly the same thing as this, right?
I agree with that.
Okay. So this is actually, this is not a very smart code here, but here I wanted to show you that if this is, okay, so maybe this will be, let's say my check, okay? And so if my check is empty, make it equal to T. Okay, but if it is not, make it equal to T. Sorry, so if this is not empty, it's T. If it is empty, it's F. So so in your program you might have some variables where you want to perform different operations if they are empty. You know, so this is actually just to check that if it is empty. Okay. Good question. Any other questions? Okay, so let's talk about while loops. So generally, this is how the while loops look like. So you start your while statement with test, which is something Boolean, either true or false. So that's the loop test. And then this is the loop body, where you have your statements. And else is optional. So else, then statements. So run if it didn't exit loop with break. If there was some break statements here, it will just run. It will just quit while. But since if there is no break break statements, then it will run this part. Okay, so for example here, this is going to give me an infinite loop, right? Because while is always going to be true. So the only way, I mean, I can run this, but so I just stopped it here. Or if you are running it in your shell, you do Control-C, basically. Yeah, too many, right? I wasn't fast enough to stop it. Or for example here, when I say while x, that's actually checking if x is empty or not, basically. So if x is not empty, then print this, and then every time you assign x to the rest of the integers. So what do you think the output of this should be? Don't worry about this and here. So it's just to print everything in the same line. Any ideas? No?
Goes down the line as well as out.
Yeah, exactly. So first x is spam, so it should print spam, and then you assign x to pam, so that it will print pam, and then it's always checking if x is still not empty, and then for the next one, it has m, and then it prints m, and then it has m, it prints m. And then after that, it will be empty, so this while will not be true anymore, right? Let's run this. Okay. So it finished the while loop because there wasn't any more letters left. Or this one. So let's say A is 0, B is 10. While A is less than B, keep printing A and then increment A by 1. And at some point, A is not going to be less than B, right? So that's how you quit the while loop. Right? So what do you think this is going to print? Right. Yes. So basically up to 10. Right? Okay, so there are also break, continue, pass, and the loop else. So break is to jump out of the closest loop, and continue just jumps to the top of the closest enclosing loop, and pass actually is a placeholder to do nothing. And the loop else block runs if and only if the loop is exited normally. So for example, this is how it generally looks like. Again, the while test statements. So you can have some if test, break. So basically that means exit the loop and skip else if there's an else present here. By the way, many programmers that I know didn't actually know that in Python you had an else statement in while or in loops. So honestly, I also didn't see too many of these, the use for else in for loops. But you know, it's good that you are aware of this. Okay. Okay, so you can do break, and it will exit the loop completely without even running else, or you can say continue. So let's see what each of these mean. So pass is basically the simplest one. That means no operation. I know that might sound a little bit strange, but sometimes you use it to, I don't know, to remind yourself that you should define something. For example, we haven't talked about functions yet, but I can write something like, for example, my function, and then pass. So I usually say that fill this later. So this is usually how I use pass. But sometimes you might have one if statement that you really don't want to do anything. You basically don't care, and you say don't affect anything. So just pass. So continue, on the other hand. So here, let's see what it does here. So we start x as 10. So while x is true, which means x is 10, then reduce the value of x to by 1, basically. And then if it is not even, continue. Don't run the rest. But if it is even, basically run this statement. So what do you think the output of this is going to be? What is the first element? First output? 8? Okay. Who says 8? Okay. Anybody says 9? Okay. Yeah, okay. I think you got the idea. So basically, for example, when it was 9, basically here it says, oh, 9 is an odd number. Just go to the next one. Okay. And for the break, so this is the first interactive loop that we started. So while true, so the user enters the name, and so if it is stop, you can. So see, this is like a one-line statement, and then you get another input, and then do this. So basically here we say break. So that means if it is stop, just stop this while loop. Just exit it. So basically, again, oh sorry, it was H. Sorry. Yeah, you see why it didn't work? Because the second entry was supposed to be H, and I didn't enter a digit, so it couldn't take the conversion. So let's run it again. So let's say Bob 25, and then I say stop, and then it exits, basically. Okay. So okay, so let's look at this. Let's see what this is really doing. This might be helpful for some, I think, programming interviews too. So let's see. So I assign y 21 as a value, and then here that actually, so here this is the division, right? So let me first show you. So if you do 21 by 2, it actually gives you an integer. So this is a quick other kind of demonstration. So this is an integer. If you do this, it's float basically. So usually in Python, this when you do double slash, that means give me the division which is integer. So that's one thing. So basically the value, let's see, the value is 10 basically. Okay, so I'll put this 2 so you guys can study it later. Okay, so divided by 2, so you'll get 10. So while x is greater than 1, so x is greater than 1, right? So x is 10 here, greater than 1. And you look at the modulus. If 21 modulus 10 is equal to 0, is that true? No, right? So I go to here and reduce x by 1. It's 9. And then I go again. 21 modulus 9, is that 0? Okay, so decrement 9 by 8. 21 modulus 8. No. So now it's 7, right? Decrement by 7. 21 modulus 7. Is this true? It's true, right? And then you say y has a factor. And then I say break. Otherwise, let's say you continue and then you never enter here, then you say that's a prime number basically. So this is a test, or this is a program that checks if the variable is a prime number or not. Okay, so let's run this a couple of times. Yes, so 21 has a factor 7. So let's try some prime number. 17. 70 is a prime because it runs all this and nothing happens, and finally it says that's a prime number. Is this clear? Yeah, I've seen in so many interview questions about prime numbers. They love this a lot. So it's probably a good thing to know how to check if a number is a prime number or not. Any questions here? No? Okay, and so we are done with the while loops. So let's do for loops. So for loop is a generic iterator in Python. So it can step through the items in any ordered sequence or other iterable object that you define. So it works on strings, lists, tuples, and other built-in iterables. So the general syntax looks like this. So for target in object, so assign object items to target. So for object for each item, so target will be like a dummy variable here, and now you run a statement. And finally you have this as statement. So again, as while, for statement also supports optional else block, which works exactly the same as while, and also break and continue statements that we introduced earlier also work the same as a for loop. So yeah, the complete format can be defined as this. So for targeting objects, statements, so basically these statements usually have something with the target. So each statement runs target. And then if test break, or if some other tests continue, as you run other statements. So for example here, so this should be super clear for you what it does, right? So what is it going to print eventually? Okay, so I'm iterating through each of these items. So x will be equal to spam first. You'll print spam. And then in the next iteration, x will be x, and then you'll print x. And then in the next iteration, x will be ham, and you'll print ham. So basically, just this. Is it clear? Very, very simple, right? Or no? What if I write one more for loop? Okay, so what do you think it's gonna give? Okay, so what is the first output of this? First output is spam, right? We first run this. And then second output is what? S, right. And then P, yeah, right. So it's clear, right? No? Maybe I should also have this and here, so they'll print them in the same line, right? Okay, so what do you think total is going to be after this, when I run this? Huh? 10? Right. So you start with total. Oh. Total. So x is equal to 1, and total was 0 before. So you add 1 to total, which is 1. And next time x is 2, and your total was 1, so you add 2 to total, which makes it 3. And for the next one, you keep adding, right? Do you have any questions? This one?
The n equal to the single comma check to the double comma. What's the difference?
Single comma? Oh, you mean it's this or this?
No. This is a single comma. Check to the double comma.
Oh, you mean this and this?
Yeah.
Okay, so when you define a list, you always use a comma. So this is when you define list or tuple, anything, you define comma. So semicolon, so this is what you are asking, right? So why not it is this? Right? So this is actually just for the end of the statements, just to indicate Python that you are at the end of the statement to use semicolon, but we never use those to define a list. Is
No, I mean the and this
you mean this end?
means the crow.
Or this? Or what's the difference between this and this?
Yeah.
The answer is there is no difference. But let's say, yeah, that's a good question. First, let's run this to show it works. So second, so the reason why you can use both of those is, let's say, another string. So I can define string. Okay, so when I define this, so it knows whatever I used as a outer, what was this called? I forgot. So basically here, so see, so it knows that that's a part of the string. But so you can iterate through a list, or you can iterate through a tuple, basically. So they both work the same way. So as long as what you are doing is an iterable that works with for loops. Okay, doesn't have to be a list. Okay, so for this one, do you think it will work? Do you think it will run, this one? Who says it fails? It will fail. No, right? Why not? I mean, so it looks at the first value. First value of t is 1, 2. So a will be 1, b will be 2. And then in the second iteration, it will be 3 and 4. So you'll have 3 and 4, and so on. Right? And you can also iterate through the keys of a dictionary. Let's say you have a dictionary like this. And when you say for each key, you can actually print key and also its value. Oh, because I didn't define this. Okay. And also Python has this dot items method that actually gives you all key and value as pairs, as tuples. And then when you run this for loop, it actually knows that. So the first item will be A1 printed. Second will be B2 and all that. But you can also do this. So when you say, for example, what was T? So T was this. So here both, in the first iteration, both will be 1, 2. And then when you run AB equals both, it actually assigns 1 to A, 2 to B. And in the second iteration, both will be 3, 4, and you can do that assignment either here or here. No, so different ways to do things. Okay, I think this is a good place to stop for this week. So next week we'll continue with this, and then also go to the how to write functions and all that. Okay. Thank you.
We have homework.
Hold on.